Rational functions. A rational function contains a quotient of polynomials, where there's a polynomial in the numerator and a polynomial in the denominator. The domain is all real numbers except for what makes the denominator 0. For example, the domain of this rational function is all real numbers except -2, because -2 would make the denominator 0. If a root of the denominator is not a root of the numerator, then there is a vertical asymptote at that x value. This means that the graph increases or decreases without bound as x approaches that value. If a root of the denominator is also a root of the numerator, then there is a hole in the graph at that x value. Here are some examples. 1 is a root of the denominator, but not the numerator. This means there is a vertical asymptote at x equals 1. Here is the graph of this function. Notice how at 1, the graph does not touch that vertical line x equals 1. It continues indefinitely this way. This one continues this way without ever touching x equals 1. For this function, 5 is a root of the numerator and denominator. This means that x equals 5, there's a hole in the curve. Here is the graph. Notice at 5, there's a hole in the curve. Notice also that x equals 0 is a root of the denominator and not the numerator. So that means there's a vertical asymptote at x equals 0, which is the y-axis. To determine horizontal or slant asymptotes, follow these guidelines. Basically, we're going to compare the degree of the numerator to the degree of the denominator. If the degree of the numerator is less than the degree of the denominator, then the x-axis is a horizontal asymptote. If the degree of the numerator is equal to the degree of the denominator, then there's a horizontal asymptote of y equals, and then you write the ratio of the leading coefficients. If the degree of the numerator is greater than the degree of the denominator, then there is no horizontal asymptote. If the degree of the numerator is exactly 1 more than the degree of the denominator, then there is a slant asymptote. This is found by dividing the numerator by the denominator and discarding the remainder. Notice that with this function, the numerator and denominator have the same degree, so that would be case number 2 on this right here. We're looking at the ratio of the leading coefficients. So that would be 2 over 1, which is 2. So y equals 2 would be a horizontal asymptote for this graph. Notice that with this one, the degree of the numerator is less than the degree of the denominator, because if you distribute this x, you get an x squared. So that means the x-axis is a horizontal asymptote for this graph. What are the asymptotes for this function? Well, to look for vertical asymptotes, we set the denominator equal to 0 to find the roots. But there's no real roots, so that means there are no vertical asymptotes or holes for this particular function. Let's look for slant, well, and horizontal. The degree of the numerator is exactly 1 more than the degree of the denominator, so there are no horizontal, but there are slant. To find the slant, we're going to divide the numerator divided by the denominator using our polynomial division. This would be 3x. Multiply 3x times this gives you 9x to the third minus 9x to the third plus 3x, and then you subtract, which gives you a remainder of -3x. Since -3x is smaller than this degree is smaller than this degree, that means that's my remainder. So the slant asymptote ignores the remainder, so the slant asymptote is y equals 3x. You just take the answer and ignore the remainder for the slant asymptote. And the graph of this function, I put the blue line as the slant asymptote. There are no vertical and there are no horizontal. So there's only one asymptote in this graph, and I use the blue line as the slant asymptote. So as the red curve is the actual graph, as this goes forever into the positive infinity this way, the red curve would keep getting closer to the blue line, and as it goes into negative infinity this way, the red curve would keep getting closer and closer to the blue line. The blue line is the asymptote. So this, as it goes up into positive infinity and negative infinity, the curve would just continue to get closer and closer to the asymptote.